Hey guys, today we're going to be starting section 8.3.1. We're also going to get through section 8.3.2. These are both pretty quick sections and something that you're already familiar with, but I thought it might be nice to kind of go through it together again. And yeah, that's about it. So what we're going to be looking at today is the area and perimeter of a regular polygon that has infinitely many sides. And I know that sounds silly, but just want you to imagine what happens if we take the polygons we've been exploring, like quadrilaterals, pentagons, hexagons, heptagons, octagons. What if we continue to extend the number of sides until it's infinitely many? What will our polygon look like? And then 2, how can we find its area and its perimeter? All right, so question 890 has us kind of thinking about all these different polygons that you see listed, A through L. There's a bunch of them. And so if we were in class together, what we would do is I would have you find the area and the perimeter of each one of these. I know you're probably having a sigh of relief right now, assuming that the radius of each one was 1 unit long. And remember, we define the radius to be a segment that goes from the center of a polygon down to one of the vertex or the vertices. And remember, the vertices are just where the two sides connect. So that's a radius in a polygon. So you could do this. You could go through every single one of these and find the area and the perimeter of each one, assuming that the radius in each one is 1. In fact, we might as well do it for one of these. Let's do it for A, an equilateral triangle. Why not? Okay, so let's say we have an equilateral triangle and we want to find its area and perimeter, and all we know about it is that the radius, okay, has a length of 1. That's all we know. Okay, we want to use that information to find the area. We also want to use that information to find the perimeter. Okay, so remember what we kind of did with these was we split them into triangles. So we can see that an equilateral triangle can be split into 3 triangles that are all the same size. And if I can find the base length and the height of each one of those triangles, then I can find the area, and then I can just simply multiply that area by 3. And we use the central angle measure to help us with that. So the central angle in an equilateral triangle is 360 divided by 3, which is 120. So we know that the entire central angle, that entire blue angle, is 120 degrees. So when I draw the height of that triangle, we have to consider what it does to that central angle. And what it does is it splits it in half. So now we're not looking at an angle of 120, we're looking at an angle of 60 right here. So that purple angle is 60 degrees. So I have a 30, 60, 90 triangle. And all I know about that 30, 60, 90 is that the hypotenuse is 1. So I'm going to redraw this because you might be a little confused and not know exactly what triangle I'm looking at. So I'm going to draw it just a little bit bigger, just so you can see it a little bit better. So here was my height. Okay, we know that this length is 1. We're looking for the base length as well. So we need to find that so that we can find the area. And then we just discovered that this angle is 60. So that's that triangle just enlarged a little bit so you can see it a little bit better. So now, if the hypotenuse of a 30, 60, 90 is 1, well, there are special rules that we can use to help us find the other two sides. So if I know the hypotenuse is 1, I can divide by 2 to find the height. So I know the height would be 1/2. Okay. If I know the short leg is 1/2, then I can multiply that by root 3 to find the longer leg. So I know the long leg is root 3 over 2. Okay, that's root 3 multiplied by 1/2. So then that tells me that the entire base length of that triangle is going to be just simply root 3. Okay. So now if I wanted to find the area of that triangle, it would be the base, root 3, times the height, 1/2, divided by 2. And there are 3 of those triangles, so I would then multiply that number by 3. So I get that the area of that triangle, if I calculate that out correctly, is approximately 3 root 3 over 4. Okay, now, if you put this in your calculator, you're not going to get 3 root 3 over 4. You're going to get that as a decimal, and that's perfectly fine. So if we calculate that out, we get that the area of that triangle, I'm going to erase this so I have a little bit more room, of that equilateral triangle is 1.299. Okay. Now, I could calculate the perimeter as well. So since I know each side length is root 3 and those three sides are all the same, I could do 3 times root 3 to get the perimeter. So if I calculate that out, I get that the perimeter is 5.196. Okay. So if we were doing this in class all together, we would go through A all the way through L, and you would simply be calculating areas and perimeters of all of those polygons because there's a pattern you need to notice. But we're not in class, so I'm not going to make you do that. Again, if you really want to, you can pause the video. You can calculate all those areas and perimeters if you want. You can come back, you can unpause it and see what they all are. But I've already done that work for you. So here are the areas and perimeters of all of those shapes. Okay, so we started with ours. They rounded to 2 decimals instead of 3, but you can see we got the same answers, okay, for our equilateral triangle. But what I want you to notice is I want you to watch how the area and the perimeter are changing as the number of sides increases. Okay, so look, as this is getting larger and larger, what number is that area approaching? What number is that perimeter approaching? And that number that area is approaching, that should look really familiar to you. Okay? What number does that remind you of? So hopefully that number reminds you of pi. And it is. It does appear as the number of sides is getting bigger, the area is getting closer to pi. As the perimeter is getting bigger, this one might be a little harder to notice. Okay? But this is simply double pi. So this is 2 pi. So as the number of sides increases, the area approaches pi, the perimeter approaches 2 pi. And remember, this is for polygons with a radius of 1. Okay, that's a very important number in this scenario. So that's pretty interesting. So now what I want you to do is I want you to think about what you would call that shape. What do you call a shape with infinitely many sides? Well, you call that a circle, right? And so here, we could honestly add a little another column if we wanted, right? And we could say that the area of a polygon with infinitely many sides, aka a circle, is pi. And its circumference, our perimeter, is 2 pi. And remember, our radius here was 1 in both of these scenarios. So I just thought that was pretty cool that you could see as the number of sides was increasing, how your area and your perimeter were changing. So hopefully that's helping you think about the area and the circumference of a circle and how to find it. And that's what we're about to go into now. So that's all we're doing in 8.3.1. So now we're going to switch gears and we're going to look at 8.3.2. So make sure you're now on that page in your textbook so that you can take notes, okay? All right, so in this one, we're going to be looking specifically at area and circumference of a circle. So not just radii of 1, like in the last section, now any radius, okay? So we're going to get a formula for those. I want you to go ahead and be thinking about that because you already know those two formulas well. And then we're also going to be looking at parts of circles. These are called sectors and arcs. Okay, I like to compare them to pi, surprise, surprise. So a sector is essentially, and we'll go over this, but a sector is essentially a whole entire piece of pie, like the whole piece. Oh, so good. Could be pecan pie, whatever kind of pie suits your fancy. I don't think we had a single pecan pie on Pie Day. That's kind of sad. And then we're also going to explore what are called arcs. I like to think that of arcs as the crust of the pie. Okay, so in terms of pie, that's kind of what we're dealing with. So if you ever get those two mixed up, think of a sector as sector, right? That's the entire piece. That's the whole thing. Whereas an arc, that's just the crust part. Okay? So that'll help you out too. So we are going to go straight into question 101. So I believe we skipped one. Let me make sure in my notes real quick. Yes, so we skipped question 100. What question 100 was trying to get you to explore was finding or discovering the formula for the area and the circumference of a circle. Again, I think that you have seen these formulas forever, so I think you probably know them, or even if you can't remember them off the top of your head, as soon as I write them down, you're going to be like, yeah, got it. Okay, I know those formulas for sure. So just to refresh your memory, I cannot get this to work. Y'all can't see what I'm doing, but I'm trying to get this little thing on my iPad to come up, and it's not working. I hope y'all enjoy all these little side notes. Okay, so if I want to find the perimeter of the circle, or what's called the circumference, there are two ways to do that. Hey, maybe you can try to write this down and beat me, okay? All right, I can use what's called the radius or the diameter. So if I want to find the circumference using the radius, that's going to be 2 pi r. Alrighty. And if I want to find the circumference using the diameter, well, the diameter is double the radius, so it's just going to be diameter pi. Okay, and then there's also one for area. Remember that area is units squared, so that can kind of give you a general idea of what you're going to be doing to the radius, which is squaring it. So the area of a circle, oh, that is sloppy. Let me try that again. The area of a circle is pi r squared. Okay, so we're going to see if we can apply those formulas to this question 101. So I want you to try this on your own. And I will say this, we'll do one together just because I want you to see how to format your answers. Yeah, we'll do two together. How about that? We'll do A and C together. Nah, let's do A and D together. And then I'm going to have you pause the video and do B and C completely on your own, and then unpause it so that you can see the solution. So A says to find the area of a circle with a radius of 10. So here we know that R is 10. So I know to use the area formula. So area is pi times the radius squared. So I can say here that the area is, and generally we put the integer in front and then we follow it with pi when we're writing our answer. I wasn't given a unit of measure here, so I'm going to put u squared. So look, there's no need to put that in your calculator. This is what's called an exact answer. If we were to put that in our calculator, it would have to round pi to be able to give us an answer. And so the most exact answer is usually the best. So just leave it 100 pi. It's actually easier. I didn't have to use my calculator at all for that. All right, let's look at part D. So part D says if the circumference of a circle is 20 pi units, I should have made you do this one on your own, then what's its area? I like it. It's got a lot of parts. So we know that circumference is 2 pi r. We also know the circumference of this specific circle is 20 pi. We want to find the area of the circle, pi r squared. So to find the area, I'm going to need the radius. So I need to find the radius. So I can go ahead and set my circumference formula, 2 pi r, equal to the circumference of the circle, 20 pi. And then I want to get r isolated. R is what I want to know here. So I could divide both sides by 2 pi. So I get that radius is 20 pi divided by 2 pi. Okay, so I can see here that the pi's cancel. Whoop, that's nice. And 20 divided by 2 is 10. So the radius of this circle is 10 units. Okay, be careful in your calculator. So if you were dividing by 2 pi in your calculator, you'd want to put that in parentheses. If not, it's going to divide by 2 and then multiply by pi. So be careful with your order of operations there. So now that I know my radius is 10, I can go back and find my area. So now I know that area is pi times 10 squared. Okay, this problem looks familiar. And so area is 100 pi. Don't forget to square that unit. Okay, so now what I want you to do, pause the video, try part B and part C, and then unpause it, check your answers. All right, so here are the solutions to part B and part C. So I thought it would be a good idea on part B to use the formula diameter pi for circumference because they gave you the diameter. You could also use the radius. Just make sure you're not plugging in 7 as the radius, that you're plugging 3.5 in as the radius. on that one if you do it that way. And then on part C, so this one was really nice. You had to find the radius given the area. So I set pi r squared equal to 121 pi, and then solve for the radius, which was 11. After that, it asks us to find the diameter, so I need to multiply the radius by 2. So you should get that the diameter is 22 units. Okay, we're actually going to skip this problem for today. If you want to do this problem on your own, that might be a good idea just to make sure you have a good understanding of circumference and area. If you do this problem on your own, you're going to get that the diameter, or the distance across, would be 102.6 divided by pi, which is approximately 32.7 feet. So if you want to do that one on your own, try it. That would be a good test to see if you have a good understanding of this or not. But for time's sake, we are going to kind of skip on to the next problem. Okay, so this is the problem I've been waiting for. So this is, again, just application of perimeter and area, but now we're going to be kind of looking at just pieces of perimeter, pieces of area, and kind of thinking about how do we find that. All right, so let's look at part A together. So it says, to celebrate their victory, the girls' ice hockey team went out for pizza. The goalie ate half of the pizza that had a diameter of 20 inches. What was the area of the pizza she ate? So let's stop there, okay? Because there's more that follows, but I've already come to a question, and I think I can go ahead and figure out the answer to this question. So I'm going to pause, and I'm going to do this first one. So we know that the diameter of the pizza was 20. We know that she ate half of the pizza. So we want to figure out what's the area of the pizza she had. So if the diameter of the pizza is 20, then I know the radius of the pizza is half of that. So the radius of the pizza in question is 10. Okay. We are given a unit of measure here, so I'll go ahead and include that as well, 10 inches. I could find the area of this pizza if I wanted to. So I could find the area of the entire pizza by doing pi r squared. Why did they love using 10 as a radius? So I get the area of this pizza is 100 pi inches squared. But how much of the pizza did she eat? Well, she ate half of it. So I could say that the area of half the pizza, the part that she ate, would be 100 pi divided by 2, or 50 pi inches squared. So she ate 50 pi inches squared of that pizza. That's a lot of pizza. Okay, let's look at the next question in part A. The next question says, what was the length of the crust? Okay, so now we're not concerned about an area, we're concerned about the crust part. How long was the crust? So we would use circumference for that. Okay, so again, I know that the radius is 10, so I could find the circumference of that pizza by doing 2 pi r, or 2 pi 10. You can also use diameter pi. And so we should get that the circumference of the pizza is 20 inches. This is just a perimeter, so it's not inches squared. But again, she only ate half of it, so the circumference of half of the pizza would be 20 pi over 2, or 10 pi inches. So the length of the crust that she ate was 10 pi inches. And if you wanted to convert these to decimals, you could as well. But it does ask us to leave it in exact form on this particular problem. All right, so let's look into part B now. I'll use a different pen color for that one. So part B says, Sonia chose a slice from another pizza that had a diameter of 16. If her slice had a central angle of 45, what was the area of the slice? So I got my first question. I'm going to stop. There's another question that follows, but we're going to look at just that first one. So there's a few things we know. Here we know that the diameter of the pizza is 16. So then the radius of that pizza would be 8. Okay. I also know that the size, or her slice of pizza, had a central angle of 45 degrees. So I want you to kind of, 45. So I want you to kind of imagine this. Let me get a circle up here so we don't have to imagine this actually. So here's our pizza, okay? She ate a slice of it, and that slice the angle measure was 45, because I don't know why we're measuring the angle of a pizza, but it's okay. So that's the area we want to find. We want to find the area of that slice of pizza. Okay, so I'm going to need to start by finding the area of the whole circle. So the area of the whole circle is pi r squared, which is 64 pi. If I can figure out the portion of the circle that 45 degrees takes up, well, then I know that that's the portion of area I want. Okay, so to do that, I know there's 360 degrees of a circle, so I could do 45 divided by 360 to figure out what that portion is. Now, you can simplify that, or we can go ahead and find the area of the slice if we wanted by doing 45 over 360 times 64 pi. Okay, now on this problem, it does not tell us that we have to leave it in exact form, but we could if we wanted, because 45 over 360 reduces to a nice little fraction, which is 1/8. Remember, you can do this in your calculator by doing math, enter. It'll convert it to a fraction. So we're looking for 1/8 of 64. We know what that is. 1/8 of 64 is 8. So the size of the slice that she ate was 8 pi inches squared. All right, the next part in B asks us to find the length of the crust. So now we need circumference. Okay, so I know the circumference of this pizza is diameter pi, or 16 pi. I also know the portion of the pizza she ate, 45 over 360, is 1/8. So the circumference of the part that she ate is 1/8 times 16 pi. 1/8 of 16 is 2. So the length of the crust that she ate was 2 pi inches. So now what I want you to do is pause, try the other two parts of the problem. It introduces you to some vocabulary words, so make sure you pay close attention to those. I should have said all three parts. I want you to do C, D, and E. I want you to try all three. And then when you unpause the video, I'll have the solutions to those so that you can check your work. Okay, so here are the solutions to those three parts. Hopefully you can read all the work clearly. On part C, it was having you use a central angle of 72. 72 over 360 is a fifth. So we're looking for a fifth of the area and a fifth of the circumference, and you wanted to make sure here you were using the Goldie's pie or pizza, which had a diameter of 20 to help you solve the problem. In part D, it introduced you the word called arc. An arc, again, is just pie crust. That's an arc. So we wanted to find the length of a piece of crust. I've given you a formula here. I don't necessarily want you to memorize this because I think that you can kind of just intuitively think about it. So if you find the circle's full circumference and then multiply that by the portion of the circle you want, you're going to have arc length. Okay, so we were looking at a 1/12 of the circle because 30 over 360 reduces to a 1/12. So if we take a 1/12 of the circumference, which is 12 pi, we get that the length of the crust was pi centimeters. And then in part E, it introduced you to a word called sector. A sector, again, is just like an entire piece of pie or piece of pizza in this case. We were looking at a radius of 10. So if I find the area of the full circle, which is 100 pi, I can multiply that by the portion of the circle I'm wanting. Since we were looking at a central angle of 20, that portion was 1/18 of the full circle. So this one didn't reduce nicely. 100 pi over 18 doesn't really simplify. I can take it to 50 over 9, but that's still just not like pretty. So I went ahead and decided just to do this one as a decimal and made sure that I used 3 decimal places. So I could say that the area of the sector in this problem was approximately 17.453 feet squared. Okay, so that's it for today. So now you can work on your assignment that is due tonight by midnight on Google Classroom. I hope you have a great rest of your day, and I will see you on your dot day.